Hi, my name is Ryan, and I am a math tutor at the Digital Learning and Academic Support Center here at Baton Rouge Community College. In today's video, we're going to learn the basic rules for logarithms with 5 sample problems. Which will probably be in some way, shape, or another on your final exam, at least one question. So the 3 rules we're going to go through are ln of a times b is ln of a plus ln of b, where a and b are real numbers. The example we're going to use is a log base 3. So log base 3 of 3x, right, that's 3 times x, and we're interested in finding x. So that is going to be log, forgive that L, base 3 of 3 plus log base 3 of x. And here we're going to mention something. Log base 3 of 3 is 1 by definition. So that's 1 plus log base 3 of x. Log base 5 of 5 is 1. Log base 7 of 7 is 1. So I just caught that really quick while we're doing this. But the example we're using is that log base 3 of 3x is log base 3 of 3 plus log base 3 of x, right? We separated and plus. And what's important here is to know that you can go the other way. If you have 2 logs that have the same base and they're added, you can multiply them inside of the log. To see, it depends on what you're trying to do. With these rules and equations, you can go both ways. So you see that with multiplication, we added, and now with division, we're going to subtract. So log base of a over b, a divided by b, is log of a minus log of b, right? So we are going to use, as an example, right, log base 3 over y, and we might be interested in finding y in this case. So our step would be log base 3 minus, log of 3 minus log of y, right? So you guys can see that. Basic log is log base 10, right? So but it's called log. So log of 3 over y is log of 3 minus log of y, okay? Now the next one, I want to give 2 examples of it going both ways, right? And this is a really, really cool property of logarithms, right? ln of a to the power of b, you can bring that b down in front, and that's b ln of a. You see, I moved this b down this way to make it b ln of a. It's outside of the ln. Likewise, I can go the other way. If I have a b ln of a, I can bring it here to make it ln of a to the power of b. So we're going to go both ways with those. So we're going to say for the first one, ln of x to the 4. And we're going to bring that 4 down in front. That's 4 ln of x. We want it to go this way for whatever reason to solve our equation. The other way would be this example here, 2 log 5 of x, and that's equal to, this time we're bringing that 2 up, right? We're heading the other way. We're saying that's log 5 of x squared, okay? So these are the 3 basic rules, right? ln of a times b, where a and b are 2 numbers, is ln of a plus ln of b, and going the other way. Log of a over b is log of a minus log of b, right? And that applies to log base, ln, right? These are all logarithms. ln of a to the power of b is b ln of a, or b ln of a, b times ln of a is ln of a to the power of b. So the next step is going to be for us to do 5 actual problems, right, in this video. And the first 3 problems, they're asking you to expand the expression. And notice here that I am repeating this one, and I'll explain why at the end of the video I'm repeating this log 3 of 3x. Well, this one is log of 3x, a bit similar. So as we did, that's 3 times x. So that's log of 3 plus, it's actually log of 3x, plus log of 3 of x. We expanded, but this here is 1. So that's 1 plus log 3 of x, right? Log 3 of 3 is 1. Log 7 of 7 is 1. So now the second one might look confusing because it's a bunch of letters. Log base b of y z to the 8. Well, that b is a number, and our unknowns are y and z. So we're just going to keep all the letters in here. So first we're going to separate with a plus that multiplication of y and z. So that is log base b of y plus log base b of z to the 8. You see, when you work math problems, you always got to ask yourself, what can I do next? Can I do something more? Well, log base b of y, that's it. But log base b of z to the 8, I can bring that 8 down in front with the third rule. So we're going to keep the log base b of y, and we're going to bring that 8 down because we are expanding. That's what they asked us to do of z. Okay? So take a second to look at our beginning and final answer on this one. Now here we have a division. And remember that with division, we're going to use the negative sign. So log base 3 of x to the 5 over y to the 6. My first step is to say that's log base 3 of x to the 5 minus log base 3 of y to the 6. Okay? And again, I ask myself, is there something else I can do? Well, yes, with both of them, I can bring the power down. See, that 5 comes in front here, and that 6 comes in front there. That's 5 log 3 of x minus 6 log 3 of y. Okay? So that's those 3 problems where they're asking you to expand, right? And we just expanded, right? We just expanded these terms as far as we could go. So now let's see working another problem, right? And this problem here is saying to solve an equation. So we're trying to find x. Now we're trying to find x. And we got some logarithms involved. But this is the basic log. Log of 3x, which is the log base 10, right? Log of 3x is equal to log 5 plus log of x minus 2. And we're going to apply some of those same rules to see what we can do. But you see that I have in light blue the word conditions. You see, you can only take the log of a positive number. So our starting condition here is that 3x has to be positive, and here that x minus 2 has to be positive. Well, here x has to be positive, and here x has to be bigger than 2 for that to be positive. So I have 2 starting conditions, right? But if you think about it, if x is bigger than 2, it's also bigger than 0. So whatever answer I find, I have to check, is it bigger than 2, right? That's my condition. Before I even start, if I solve this and I find a number that is not bigger than 2, it's not valid because I couldn't do it to start with, right? So that was our starting condition. Now let's work this. I'm going to leave that x bigger than 2 right here for now. We might have to come back to it. So on the right side, I have a plus. I can multiply those because I don't have any numbers in front. So this becomes log of 3x is equal to, right, log of 5 times x minus 2, right? I can multiply the 2 because there's a plus in front. Well, log of this and log of this are equal to each other, so those two have to be equal to each other. So now we can pull out 3x equals 5x minus 2. I multiply that 5, right? It's called distribution, like making sure everybody gets their share of food on a team. So now I have this equation. It's a linear equation. You've been doing this since the beginning of the semester. I'm going to do it step by little step. I want to get all my x's on the same side. I'm keeping 5 because it's bigger. This is 0. So 0 is equal to 2x minus 10, right? Now I'm going to do plus 10. To get rid of that 10, I got to do it to each side. So 10 is 2x, right? X is going to be 5, but to show the steps, divide by 2 to get rid of this 2. 10 divided by 2. So x is 5. But we had a starting condition. We have to check this, okay? There you go. X has to be bigger than 2. Is 5 bigger than 2? Yes, 5 is bigger than 2. So this is valid. This answer here would be valid. If we wanted to check it, we would plug it in and see if we got in the original equation and see if we got an equality on each side, right? Now moving on, let's do problem number 5, which is use properties of logarithms to condense, right? And I want to read this to you. This is 2 log base 4 of x plus 1/3 log base 4 of x plus 5 minus log base 4 of 6x. So we got plus and minus and some expressions, but they're all log base 4. They're all log base 4, so we can do something with them, right? But my little note in light blue says review basic rules. So we are going all the way back to the beginning. The first rule, because we're going in reverse this time, we're condensing, is that if I have ln of a plus ln of b, that's multiplied, ln of ab. Notice there's no numbers in front of those ln's, right? Because I can't do that unless it's all in the ln's. Next, I have ln of a minus, well, in this case I use log of a minus log of b. That's log of a over b, right? That minus sign came from a division. And then the cool rule, which is b ln of a is ln of a to the power of b. So now let's go back to problem number 5. In problem number 5, we have some numbers in front of those log 4 of x. So we can't multiply or divide until we do something with those numbers. And what I'm going to do is use rule number 3 to bring those powers up. I don't have it for the last term. So this is log base 4 of x squared plus log base 4 of x plus 5 to the power of 1/3 minus log base 4 of 6x, all of that in there. And remember, we're not expanding. We're trying to get it all together. That's what condensing means. We're trying to get it all together. So that plus is going to be multiplication. That minus is going to be division inside of our logs, as long as it's the same logs. And in this case, we all have log base 4, so it's the same logs. So let's do the first two. We can multiply them in there because there's a plus. So this is log base 4 in here of x squared times x plus 5 to the 3rd, all of that in there. And we still have this minus log base 4 of 6x. Okay, now we can use that minus to create a division. So our final answer, right? Our final answer is going to be log base 4 of, let me show what we got, right? X squared, x plus 5 to the 3rd at the top of our fraction, our top of our division, over 6x. That is the final answer to this problem. And I'm gonna give the conclusion before we review our 5 problems, right, that we did. Okay. The conclusion is that I did not want to stress you guys out watching this video, but the 5 problems that we chose were sample final exam questions that were asked in previous semesters. So you just did in this video some final exam questions, right? The numbers may have been changed, but you just did with me, we did together, right? So this is problem number 5, right? Where we condensed everything and we started by putting those powers in there so that we could do the multiplication and the division. This was a problem involving an equation, and we had to condense the right side in order to set an equality and pull out our x's, right? And it could end up being a quadratic equation. It could be more complicated than a linear. Remember that your math builds up, okay? And here, these 3 was just expanding. And generally, when you're expanding, if you can evaluate something without a calculator, you do. Like we did that log 3 of 3, which was 1, right up here. And our basic rules, right? Our basic rules right there. So this was a video on the very end of college algebra. Again, there's a previous video on exponents, which are also covered with logarithms, and there's a relationship between the two to solve even more types of problems.